Hello everyone, welcome to Abhi online classes. So far we have discussed about the convergence or divergence of a series of positive terms. Today I am going to explain about a series which contains an infinite number of positive terms and an infinite number of negative terms which may either converge or diverge or oscillate. That is, I am going to discuss about an alternating series. Let us see. What is an alternating series? It is a series whose terms are alternately positive and negative is called an alternating series. It is in the form of u1 minus u2 plus u3 minus u4 and so on minus 1 whole power n minus 1 into un and so on. This is an alternating infinite series where un is positive for all n. It is denoted by sigma n is equal to 1 to infinity minus 1 whole power n minus 1 into un. This is an alternating series. Therefore, sigma n is equal to 1 to infinity minus 1 whole power n minus 1 un is equal to u1 minus u2 plus u3 minus u4 and so on minus 1 whole power n minus 1 into un plus and so on. This is an alternating series. We have one test, that is Leibnitz test, or you can pronounce it as Leibnitz test, which is also called alternating series test. It is an infinite series sigma minus 1 whole power n minus 1 un in which the terms are alternately positive and negative. This alternating series is convergent if the following two conditions are satisfied. First condition is each term is numerically less than the preceding term, that is un plus 1 is less than or equal to un for all n, that is un greater than or equal to u2, u2 greater than or equal to u3, u3 greater than or equal to u4 and so on. That is each term is less than its preceding term, that is it is monotonically decreasing. And the other second condition is limit n tends to infinity un is equal to 0. That is un tends to 0 as n tends to infinity. That is the two conditions, once again I repeat. Each term is numerically less than its preceding term and limit un equal to 0. That is un tends to 0 as n tends to infinity. If these two conditions are satisfied, then this alternate infinite series is convergent by Leibniz test. First we see one problem. Test the convergence of the alternating infinite series 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5 minus 1 by 6 and so on. The given series is an alternating series. Obviously it contains infinite number of positive terms and infinite number of negative terms. So obviously it is an alternating series. We call it as sigma minus 1 whole power n minus 1 into un, which is equal to 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 and so on. This is u1 and this is u2, this is u3, this is u4 and this is un. Un is positive for all n. Here un is 1 by n, which is positive for all n. First we check each term is numerically less than its preceding term or not. That is, it is monotonically decreasing or not, we see. Just we replace n by n plus 1. That is un plus 1 equal to 1 by n plus 1. Un plus 1 minus un, we subtract this to 1 by n plus 1 minus 1 by n. On taking LCM, n into n plus 1, this is n minus of n plus 1, cancel n, and this is equal to minus 1 by n into n plus 1, which is negative for all n. Un plus 1 minus un is less than 0 for all n. That implies un plus 1 is less than un, that is each term is numerically less than its preceding term, that is it is monotonically decreasing. That is one condition. Next, another condition is limit n tends to infinity un is equal to limit n tends to infinity, here un is 1 by n. As we all know, as n is tending to infinity, 1 by n tends to 0. Therefore, the second condition of Leibniz test is also satisfied. Monotonically decreasing and limit un 0. Therefore, by Leibniz test, the given alternating series is a convergent series. This is a convergent series. Now we'll see one more problem. Test the convergence of an alternating series 1 by 1 into 2 minus 1 by 3 into 4 plus 1 by 5 into 6 minus 1 by 7 into 8 plus and so on. Obviously it contains positive terms as well as negative terms. Therefore this is an alternating infinite series. We call this as sigma minus 1 whole power n minus 1 into un. Now we find out, first of all, this is u1, this is u2, this is u3, and next one u4, and first we find out un. How to find out nth term? Here the first terms are 1, 3, 5, 7, all these are odd numbers. Therefore nth term of odd numbers is 2n minus 1. Numerator value all are 1 equal to 1 means therefore we take 1 as numerator. Denominator, the first terms are 1, 3, 5, 7 are all odd numbers. The nth term of odd numbers is 2n minus 1. Whereas the second terms 2, 4, 6, 8 all are even numbers. The nth term of even numbers is 2n. Clearly this is greater than 0 for all n. And we find out un plus 1. By replacing n by n plus 1. 2 into n plus 1 minus 1. 2 into n plus 1. Therefore, this is equal to 1 by 2n plus 2 minus 1 plus 1. 2n plus 2. Now we subtract un plus 1 minus un. This is equal to 1 by 2n plus 1 into 2n plus 2 minus 1 by 2n minus 1 into 2n. Now taking LCM, all are different terms, 2n plus 1, 2n plus 2, 2n minus 1, 2n. This is 2n minus 1 into 2n minus of 2n plus 1 into 2n plus 2. On multiplying 2n into 2n 4n square minus 2n minus 4n square, 2n plus 4n 6n minus 6n minus 2 by 2n plus 1 into 2n plus 2 into 2n minus 1 into 2n. Cancel 4n square. This is equal to minus 8n minus 2 by 2n plus 1 into 2n plus 2 into 2n minus 1 into 2n. We are getting negative quantity, that is it is less than 0 for all n. Therefore, un plus 1 minus un less than 0 for all n. Un plus 1 is less than un for all n. Therefore, each term is numerically less than its preceding term. The first condition of Leibniz test is satisfied. Now we will see one more second condition. Limit n tends to infinity un. Limit n tends to infinity un here is 1 by 2n minus 1 into 2n. As n is tending to infinity, 1 by n tends to 0. Therefore, 1 by 2n is also 0. 0 into something is 0. Therefore, the second condition of Leibniz test is also satisfied. First condition is each term is numerically less than its preceding term. Second condition is limit un 0. Both the conditions of Leibniz test are satisfied. Therefore, by Leibniz test, the given alternating series is convergent. Therefore, the given series is an convergent alternating series. Hope you understood this class. Thank you.